Okay, today we're going to talk about the normal distribution. Okay, suppose that our continuous random variable is x. And what if I told you that x has a normal distribution? Let me show you a picture of what that will look like. Okay, that's what a normal distribution looks like. Now let me point out a few things. When you see this right here, that is saying the variable x has a normal distribution with mean mu and standard deviation sigma. Okay, that's what this stuff up here means. You will usually see it worded this way. Instead of x has a normal distribution, it usually is worded this way. X is normally distributed. With mean mu and standard deviation sigma. Okay, now let's look at that graph. Let's look at this picture right here. What that graph is showing is the layout of all the different x values. So let's make this concrete in your mind. Let's pretend that these are the test scores from a class taking a midterm exam. Okay? And what if I told you the test scores were normally distributed? Then that means if I graph the test scores, the graph will look like that. This is what you oftentimes hear of called a bell curve, right? That's what that is. It's a bell curve. And the average is right in the middle. So what can you see from this bell curve? You can see that most people in the class got scores that are close to the average because the bell curve is high in that area. And you can say that there's very few people got super high scores because the curve is low in that area. And also very few people got terrible scores because the distribution of the scores is very low in that area. Okay? That's what a normal distribution is. And the average is right in the center of the bell curve. And then the bell curve drops off the further away you get from the average. Now, how fast does the bell curve drop off? That all depends on the standard deviation. So the mean is right in the center of the bell curve, and the standard deviation determines how spread out the bell curve is. If the standard deviation of the test scores was very small, then that means the test scores would not be spread out very much, and you would have a bell curve like this. Okay, that's if you have a small standard deviation. Okay? The scores are not spread out very much. So all of the scores would be very close. Well, I shouldn't say all, but let's say this. Most of the scores would be very, very close to the average. If you had a large standard deviation, then that means the scores would be spread out much more. And so the bell curve would look more like this. Very spread out bell curve. That's if you had a large standard deviation. Okay? But no matter what, the total area under the bell curve equals 1. Because that's how it always is for a probability distribution. The area underneath the curve is always 1. So if the standard deviation is small, then the bell curve is very narrow, but also notice that it's a lot higher in the middle. Because if the bell is very narrow, then it has to go a lot higher in order to fit an area of 1 underneath the bell. If the standard deviation is very large, then the bell is much more spread out, and so the center is much lower, because you have the same amount of area underneath the bell, no matter how spread out it is. The area is always the same, and the area equals 1. So small standard deviations give you a narrow, tall bell curve, and large standard deviations give you a wide, short bell curve. Okay? All right. So let's move on from here. Still talking about standard deviation. What have we said just a minute ago? We said the standard deviation determines how spread out the bell curve is, right? In fact, there are some exact numbers that are good to know. Okay, what I would like you to know is that about 68% of the scores, or if you want to say the values, that's fine, let's say X values, lie within 1 standard deviation. I'm going to start abbreviating standard deviation now, okay, so we don't take so long to write it out every time, because we're going to be writing it several times. About 68% of the X values lie within 1 standard deviation of the mean. So what that means is if you go to the mean, mu, which is right in the center of the bell curve, okay, and then if you go 1 standard deviation in each direction, then you are guaranteed about 68% of the scores lie within that region right there. Okay, about 68%. So that area that I just shaded in blue is approximately 0.68. Okay? That is roughly 2/3. So if you take an exam and your professor tells you, okay, the exam scores were normally distributed with the mean of, let's say, 75 and a standard deviation of 10, then you know that about 2/3 of the class got test scores between 65 and 85. That's the mean plus or minus 10. Okay? All right, now if we want to go a little bit wider from there, I can say that about 95% of the x values lie within 2 standard deviations of the mean. Okay, so if we go now from the mean to standard deviations in each direction, then we know that about 95% of the scores lie in that region. So that area is about 0.95. So again, if you have a test and the mean was 75 and the standard deviation was 10, 75 minus 20 is 55, and 75 plus 20 is 95. And so you would know that about 95% of the class got scores between 55 and 95 on the test. Okay? All right. What if you go out a third standard deviation from the center? About 99.7% of the x values lie within 3 standard deviations of the mean. So that means almost the whole thing, 99.7% of the area. So that's almost all of the area lies within 3 standard deviations from the mean. Okay? So there's very, very little area out here and here. In fact, we could figure out how much area, because you know the total area under the curve is 1. So if you take 1 minus 0.997, what's that give us? That gives us 0.003, right? So these two together add up to 0.003. If you divide that in half, then that is 0.0015 for each of those areas. This is approximately. Okay, so there's approximately 99.7% of the scores are in the middle area, the mean minus 3 standard deviations to the mean plus 3 standard deviations. And then there's about 0.15% that are larger than the mean plus 3 standard deviations. And there's about 0.15% that are smaller than the mean minus 3 standard deviations. Okay, that is a very good rule of thumb to remember. And this rule is usually called the empirical rule. I misspelled it there. That E is actually an I. Okay. You can also call it the 68, 95, 99.7 rule. Okay. Now, how would you use this information to calculate something? Okay. Suppose that you were told this information. Okay, suppose you were told that x is normally distributed with a mean of mu. That means that they would tell you a number, like it could be 75 or something, and a standard deviation of sigma. They would tell you a number for sigma. And what if you were asked, what is the probability of x being equal to or greater than and then what if they gave you some number? Let's just call it x1. Okay, so what if you were asked that question? What's the probability of x being equal to or greater than some number x1? Okay, I'm going to show you what that probability would look like in the picture. Okay, so what you would do, this is just in theory, okay? I just want you to understand the idea, and then I'll talk to you about how to actually do the calculations. But right now I'm just talking about the idea. So the idea is, if you want to calculate the probability, here, let's write this in purple. If you want to calculate the probability that x is equal to or greater than some number, then what you do is you would find that number on the x-axis and you would find this area right there. That area is the probability that x is equal to or greater than this number. Okay? And if it just said greater than instead of equal to or greater than, then it would be the same answer. Okay? Now, if you were asked this question, what is the probability of x being less than some number? Let's still use the same number, x1. Okay, then what you would do in that case is you would calculate this area, the area to the left of x1. Okay, that would be the probability that x is less than x1. Okay? Now, let's erase that second question. You can always rewind the video and look at it again if you want to. Okay, what if you were asked this question? What is the probability the probability of x being between two values? Let's say between x1 and x2. Okay, well, let's look at that picture. Okay, for that one, you find the number x1 and you find the number x2. And then whatever area is between those two, that would be the probability that x is between x1 and x2. Okay, so that's the idea. If you want to find the probability that x is greater than some value, then you want to find the area under the curve to the right of that value. If you want to find the probability that x is less than some value, you want to find the area under the curve to the left of that value. And if you want to find the probability that x is between two values, then you want to find the area under the curve between those two values. Okay, that's the idea. Now, the next question becomes, how do you calculate that area? So how do you find out what that actually equals? What is this area here? Or what is that area there? Okay, the answer is you don't calculate it. It's already been calculated for you. Okay, I'm going to show you where to look those numbers up. Okay, what if you're given this information? So what does that mean right there? Look at what I wrote. What does that mean? It means that x is normally distributed, and it means the mean is 0 and the standard deviation is 1. Okay? And what if I asked you this question? Find the probability that x is less than, what if we said something like 2.35? Maybe that's a little large. Let's say 1.35, okay? Find the probability that x is less than 1.35. So, based upon the discussion we had just a minute ago, you understand the idea. The idea is that you have a normal distribution, so a nice bell curve. The mean is 0. And the standard deviation is 1. So what does that tell us? The fact that the standard deviation is 1 tells us that, let's just review the empirical rule. It tells us that about 68% of the area is between -1 and +1. About 95% of the area is between -2 and +2. And about 99.7% of the area is between -3 and +3. Okay? But this question is asking us, what's the probability that x is less than 1.35? Okay, so where would 1.35 be? Right about here, right? So let's erase that other stuff then. Okay, what we want to do is we want to find this area right here. And just a few minutes ago, I promised you that you would not have to calculate this area because it's already been calculated for you. All I need to show you is where to find it. Okay, but you understand that that's what we're going to try to find though, right? Is that area. Okay, so where are we going to find that area? Number one, let me point out something to you. That distribution, when it's normal and the mean is 0 and the standard deviation is 1, that is called the standard normal distribution. Okay? And one other thing, this is not a rule that has to be this way, but it's just the way it is in every single statistics book probably ever written, is that when the distribution is the standard normal distribution, you will always see that they call the variable z instead of x. It doesn't matter, it's just a variable. You can call it anything you want, but let's go ahead and stick with that. I know I called it x, but let's go ahead and call it z because it's always that way in the textbooks. Now, if the mean was not 0 and the standard deviation was not 1, then they would use an x. But when the mean is 0 and the standard deviation is 1, they always are going to use a z for the variable. And so it's good to stick with that. Okay? Now the question is, once again, how are we going to find that area right there? Okay, so in the back of the book is a table with a whole bunch of areas written down for you. I'm going to show you how to use that table. Okay, I'm also going to show you how to use Microsoft Excel to calculate it as well. It's very easy. It's just a matter of typing in one command and it'll tell you what the area is. Okay, but first let me show you how to use the table in the back of the book. Okay, now in the back of the book on page 607, it's called Appendix A, and you will see this table. Okay, there's a whole bunch of numbers in that table, correct? What do those numbers represent? Look at this picture right here, which is also, I believe, back there in the back of the book, just by that table. I think right before the table is this picture that I just circled. Okay, so you see this area right here? That's what each of these numbers represents. Okay, so what I mean is this. So our value is 1.35. That's what we were asked about. So what you do is you look up 1.35 on the margins here, and here. How do you do that? Okay, here's what you do. The first two numbers are along the side. Okay, so I go down the left side and I look for 1.3. So that's right here. 1.3. The second decimal place you look for along the top. Our second decimal place is a 5. So I go along the top to where it says 0.005. So these two together, 1.3 combined with 0.005 is 1.35. Okay? What you do then is you go across that row and down this column to find the cell where they cross. So let's just highlight that one cell. Would be right here. What number is in that cell? It's 0.4115. So this area right here is 0.4115. That's not the answer to our question. Let's look back at our question here. Our question says, what is all of this area? So what we have found so far one second here, let me fill this back in. So what we have found so far is this area right here. Between the middle at 0 out to the value of 1.35, we found that area, and we found out that it is how much? It is 0.4115. Okay? Now, how much area is out here? The table did not tell us that. But that's okay. We already know. That's half of the curve. And how much area is under the whole curve is 1. So half of it is 0.5. So what is that total blue shaded area? The total blue shaded area must be 0.9115. And that's the answer to our question. The probability that z is less than 1.35 is 0.9115. And that's how you use that table in the back of the book. Okay? Now, let me show you how to find the answer using Microsoft Excel. Okay? So let's get rid of this table. Okay, let's go back to our original question here, where we had z is normally distributed with a mean of 0 and a standard deviation of 1, and it says find the probability that z is less than 1.35. Now, if you have access to Microsoft Excel, they have this command already built into it. Click on any cell you want. I'll just click over here. Okay, and then you type in equals, and then we're going to use all caps here, and you type norm dot s dot dist, open parentheses, and then you type in the value that we were given, which is 1.35, and then comma, and then you type the word true, and then close parentheses, and hit enter. And look what it gives you right there. It gives you our answer. Whoops, hold on a second. It gives you our answer right there, 0.911492. Sorry, I keep making that disappear. So that is how much blue area there is. And that's the probability of z being less than 1.35. So which method do you like better, looking it up in the table or using Microsoft Excel? You're going to have to decide for yourself. Either one is fine. I will point out why I think using Excel is easier. Number one, I think it is just as fast to type in that one command as it is to flip to the back of the book and look up a number in the table. But also, I want you to remember that when we used the table in the back, it didn't give us the answer of 0.911492, did it? It gave us something like, I don't remember the exact number, but I believe it was something like 0.4114 or 0.4115, something like that. And we had to add the additional 0.5, remember? If you don't remember that, then rewind the video and look. It gave us the 0.411 part, and we had to add the additional 0.5 ourselves. When you use Excel, it gives you the whole area. So it saves a little bit of work. Something else that's a benefit of using Excel is the answers are more precise, meaning it gives you further decimal places. So that means that there is less rounding off. And so that's better as well. Okay, now let's move on to a new question. Okay, let's look at this question out of the book. Example 6.3, and this is coming from page 284. Okay, it says the final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Okay, so the scores were normally distributed. We'll use x as our variable. X is normally distributed. The mean is 63. And the standard deviation is 5. So I already have in my mind an idea of what the bell curve looks like for these scores. The center is at 63. And what does the standard deviation being 5, what does that tell me? Well, remember the empirical rule? That tells me a few good pieces of information. For instance, I know that if I go from 58 to 68, I know that approximately 68% of the class has test scores in that range. If I go from 53 to 73, I know that approximately 95% of the class has test scores in that range. And if I go from 48 to 78, I know that approximately 99.7% of the class has test scores in that range. Okay? But what is it that they're going to ask us, though? Let's look at the questions. Find the probability that a randomly selected student scored more than 65. Okay, we'll do that. Find the probability that a randomly selected student scored less than 85. I'm going to change that. I find that question to be a bit misleading because practically everybody in the class scored less than 85. So I'm going to change that number. Let's make that 78 instead. Or maybe even maybe even a little smaller. How about we'll make that 71. Okay, and I'm going to add a question C, which will say find the probability that a randomly selected student scored between 60 and 70. Okay, let's answer those three questions. Now, I think the easiest one is B. Let's do that first. It's the most straightforward. So let's do that question first. Okay, so what are they asking us to do? They're asking us to find the area under the distribution on the left of 71. So let's say 71 is right about here. It doesn't matter if I'm drawing it in the accurate place or not, because I'm not going to rely upon my picture for the measurements, okay? The picture is just a visual aid. They are asking us to find this area right here. That is the probability of a randomly selected student scoring less than 71. That's what we want to find. Okay? Now, there's a bit of a problem we run into. We do not have a table in the back of the book for this distribution. And Excel does not have the numbers for that distribution programmed into it. The only distribution that we have numbers for is the normal distribution with a mean of 0 and a standard deviation of 1. We don't have the numbers for the normal distribution with a mean of 63 and the standard deviation of 5. Only the normal distribution with a mean of 0 and standard deviation of 1, the one that we call the standard normal distribution. That's the one that has the numbers in the table at the back of the book. That's the one that has the numbers programmed into Excel. That one looks different. First of all, the center is at 0, not 63. Second of all, the standard deviation is a lot smaller, so it's going to be taller in the middle, and the bell will be more narrow. Okay? So we have the numbers for this one, not this one. But we are asked a question about this one. So how are we going to answer it? Here's the trick. There is a place in the standard normal distribution. There is a place where this area to the left right there will equal the area we're looking for. Same area. So what we're going to do is we are going to look up this area in the standard normal distribution, and that will tell us what this area is. Okay, now the trick is, in order to look up that area, we need to know this value to look up. So we have the number 71 in this distribution, and the question is, what does that correspond to over there? What's the correspondence? Now, there's a simple formula for this, and you're going to need to know this formula. This is called a z-score. We want to find the z-score for 71. Okay? And the formula is z equals x minus mu over sigma. That's the z-score formula. Write that down somewhere because you're going to need to use that formula over and over and over again. Okay? So for us, our z-score is going to be 71 minus 63 over 5. What does that equal? That equals 8/5, which is 1.6. I'm going to write 1.60, okay? That is our z-score for 71. 1.60. Now, we're going to look this up in the standard normal distribution, and it's going to tell us this area. And since that's equal to this area, then that'll give us our answer. Okay, so let's look it up. We'll do it using the table in the back of the book, and then we'll also do it using Excel. You should practice both ways. Okay, so I'm going to have to scroll down so that we have some area. So the picture is going to go away for a minute. So you need to remember what we're doing. We're looking up the z-score of 1.6 in the standard normal distribution. Okay, so let's do that. Okay, so I want to look up 1.60. So I go down the left-hand column, the margin. There's 1.6. Along the top, I go to 0.00. So that's going to tell me 1.60. Okay. Where do those cross? They cross right here. What number is that? 0.4452. So that is, remember, this area right here, 0.4452. Now remember, we would like to find the whole area all of the way to the left end, not just from 1.6 to the center, which is what the table has told us. We want the area from 1.6 all the way over to the left. Okay, so what do we have to do? We need to add on this, which is 0.5, remember. And so our total area is going to be 0.9452. Okay, you followed that? It's 0.5 plus 0.4452, so it's 0.9452. That is this area here. Okay, you can actually still see the picture there. Okay, so the table told us that this is 0.4452. We know that this is 0.5 because it's half of the bell curve. Half of 1 is 0.5. So together, that whole area is, that whole area is 0.9452. Now, the area we're looking for is the same size. That's the magic of the z-score formula. So that means our area is also 0.9452. So I can say the probability, let's scroll up here to the question. The probability that x is less than 71 equals 0.9452. And that's my answer for part B. Okay? Now, for practice, let's find that same answer using Excel. It is, I think, quite a bit easier. Okay. In Excel, all we have to do is type in norm. Well, don't forget the equal sign. That's important. Okay. We type equals norm.s.dist, and then in parentheses I put 1.6, then comma, true, and then we hit enter, and it immediately gives us the entire area, 0.945201. So let's write that in. 0.945201. You see, that's much faster, isn't it? Because I don't have to add the extra 0.5. And also, it gives me a more accurate answer, more precise. It's giving me an answer to 2 decimal places more than I got from the table. I think using Excel is much faster. Okay, so that's the answer for part B. The answer is 0.9452. Let's go ahead and put the 01 on there, okay? All right, let's go back now and do question A. So question A says, find the probability that a randomly selected student will score more than 65. Okay. So let me show you how to do that. So 65 would be right about, let's say, here. It's not very far past 63. Here's the catch this time. They want to know the probability of scoring more than 65, so we need to find this area. How do you think we're going to do that? Here's what we're going to do. We're going to find this area, just like we did in the last problem, and then we're going to subtract that from 1, and that'll tell us this area. Okay? That's really the only way to do it. Okay, so we find the z-score. For 65. Z equals your x value minus the mean of the distribution divided by the standard deviation of the distribution. So that comes out to 2/5. So that is 0.4. Okay, that's my z-score. Let's go ahead and write 0.40. Okay, and here's what I'm going to do. We use the chart in the back of the book, or we use Excel, and we are going to find this area right here. Okay, so let's do that with the chart in the back of the book. So our z value is 0.40. So let's find that in the table. 0.40. What do we find in the cell where that row and column intersect? We find 1.554. Sorry, 0.1554. Okay, so that means in our picture up here, we have right here, we have 0.1554. And we know that right here is 0.5. So that tells us the total area that I have shaded in bright blue over there is how much? 0.6554. So the area that I'm looking for must be how much? It's 1 minus 0.6554, which is going to be 0.3446. And that's the answer to our question. The probability of x being greater than 65 equals 0.3446. Okay? Or, what's our other option? Our other option is to go to Excel and type in equals norm s dist parentheses 0.4 comma true, and you see it gives us immediately 0.655422. So this is 0.655422. 655,422, which means our area that we were looking for is 0.94458. Sorry, I made an error, didn't I? That should have been a 3, not 9. What am I talking about? 344,578. Sorry about that. Didn't mean to confuse you. Okay. So that's how you do that kind of question. Erase this stuff here. And there's our picture that goes with this answer. Okay, we'll do more practice in the next lecture.